So this is our 2023 test, question 5. So it says the functions are, well, it says twice differentiable. That means you're like extra good. You can do derivatives and then derivatives again. And then they give us some values in the table. Let h be this function, find h prime of 7. Okay, we're going to find h prime of x and then separately do h prime of 7. If you link those two things together, that is what's called a linkage error. What derivative rule is this? For f of g of x. Chain rule. This is your basic chain rule. Do you remember the bubble sheet that we did? This literally is just that rule. So how do you write it? F prime, good, g of x, and then times g prime of x. Good. Now we're going to plug in 7. So you're going to start right here with g of 7. So I'm going to go to the table. What is g of 7? 0. Do you see that there? I don't have a better explanation than it's right there. All right, so this part is 0. Now we're going to do f prime of 0. So f prime of 0 is 3/2. So this first part is 3/2 times, and then we're still plugging in 7. So g prime of 7 is 8. You do not need to simplify that down, so please don't. Let me share my screen. We'll look at the scoring guideline. It was worth 2. A point for the chain rule and then a point for the answer. If you got it both, give yourself 2 points. That was pretty straightforward. All right, letter B. Let k be a differentiable function such that, now did they give you k? No, they gave you k prime. Now they ask about concavity. Concavity is which derivative? Okay, so they gave you the first derivative. We're going to do the derivative of that and get the second derivative. Positive means concave up, negative means concave down. 2 rules going on here. First of all, what rule do we need for this? Product rule, good. And then chain rule. Okay, so both. So how does product rule start? Because this is going to be very long, right? The first thing, which is f of x squared, times derivative of the second thing, which would be g prime. Perfect. First times derivative of the second. Plus the second thing, which is g, derivative of the first. Now here's where your chain rule comes in. You bring the 2 down. I'll put a little dot here. And it's going to drop to the first. That confuses people because when it drops to 1, we don't write the 1 anymore. Do you get what I'm saying? But it's f of x to the 1. And then you chain on f prime of x. All right, so the 2 came down. This drops to, I guess you could put a 1 there if you want. I don't know. I feel like that looks like a prime mark, so I don't like to put it. And then f prime of x. Now, what are we plugging into that? At what point are we talking about? 4. Now, scavenger hunt, you're going to just find all those values from the table. I don't want to keep moving my paper up and down. So can you just look at your table here and we'll all stick together? What's f of 4? We just got to find all these. 4. Okay, so 4 squared, 16. All right, g prime of 4 is 2 plus, all right, g of 4, negative 3 times 2. All right, and then f of 4, was that 4? And then f prime of 4 is what? 3. Now, I don't care what that actually comes out to. This is not calculated. We just need to know if that result is positive or negative. This first part would be 32, and then this is going to be negative. Would this be more than 32? Okay, so the whole result is going to be negative. Okay, so we're going to say k of x is, and how does the rest of our sentence go? All right, concave down at x equals 4 because k prime prime is negative there. And I believe this was worth 3 points. I think it was 1, 2, 3. But hold on, let me go back to the scoring guideline and we'll see. Yeah, your product or chain rule, thing that value for k prime prime at 4, and then your answer with your reason, which is your sense. So yeah, 3 points, like a point for each thing. I'm hoping to get you to the point where when you get your test in front of you, you go, oh, this is probably worth 2 points, or oh, this is probably worth 3 points. Like we'll have done enough of them that you can sort of anticipate what it's going to be worth. Part C, now they give you a new function. M of x is this thing. Find m of 2. All right, cool. We're going to plug 2 into that function. So that would be 5 times 2 cubed plus integral 0 to 2 of all of that. That's not going to be worth a point yet because we didn't really do anything. I just took 2 and plugged it in. Are you all with me so far? Okay. This is your fundamental theorem of calculus. This is where it's going to be worth a step. You can write 5 times 2 cubed, but here, let me work that out. 2 cubed would be 8 times 5, 40. I got lazy. I didn't feel like writing the whole thing again. Now you have an integral of a derivative. So if you have f prime and you do the integral, that takes you backwards to f. Good. So it is f of x such that 0 to 2. I'm pretty sure that's where the first point comes in, is doing the fundamental theorem of calculus. All right, and then it is upper minus lower. So we're going to do f of 2 minus f of, oh, I'm remembering this on the test now. Almost everybody ignored the f of 0. F of 0 is not always ignorable. I'm not sure if that's a word, but like f of 0 is not always 0. Sometimes it's another number, because I remember almost everybody got here and got f of 2 and then ignored this part. You can't always ignore it when it's 0. All right, what is f of 2? Just looking at your table. 7, and then minus lower boundary, f of 0. I remember almost everybody wrote 47. I'm remembering that now. Don't ignore the lower boundary. Let's see what that was worth. Oh, I remember this now. It's only worth 1. You either got it or you didn't. I think that's rude. I feel like it should have been 2, in my opinion. I feel like if you got, oh, and you know what? I actually felt so strongly about it. I made it worth 2 on my test. I made it a point for getting fundamental theorem of calculus. So if you got here, you got a point. And then if you got the answer, you got a point. So a lot of you got 1 out of 2 for me, because I felt like it should have been worth 2. But they only made it worth 1. So you either got it or you didn't. All right, last part. We can get this done before we go to lunch. We got plenty of time. Is that function m defined in part C? So we're going to use this same function, increasing, decreasing, neither, or 2. We're basically going to repeat the process we did for part B, except instead of concavity, which is second derivative, we're going to do increasing and decreasing, which is just first derivative. Okay, so we're going to find m prime. We're going to plug in, what is the value that they are at 2. Positive means increasing, negative means decreasing, just like your sticky note. All right, so derivative of 5x cubed be 15x squared plus, now if you do the derivative of the integral, they cancel, and all you do is take x and plug it in. Do you remember those ones where you just take that upper boundary and plug it in? So it's just going to be the insides, which is f prime. So I just took that x and whatever it says inside of there, that's what it is. All right. Now we're going to plug in 2. 2 cubed. 2 squared. 4 times 15 is 60. But you could write 15 times 2 squared. You're within your rights to do that. All right. And then from your table, what is f prime of 2? -8. And that whole result, is it positive or negative? So here comes your sentence. Drilled these sentences into you. M of x is increasing at x equals 2 because m prime is positive. So part A, they give you the answer. They're asking you to show that. So they're telling you that is the derivative of this equation. We just have to go through and take the derivative. So what rule do you need for this first part here? It is going to be product rule. The first thing is 6x. Y is the second thing. But whoever said chain rule, you're right too. Anytime you do a derivative of y, you chain on dy dx. And if you're like, hey, I'm scared I'm going to forget the dy dx, I hope you won't, because it says dy dx right there. So it's like a big clue. All right, so the first thing, which is 6x, derivative of y, which we just said, dy dx. So first times derivative of the second. I'm going to move this up because you have the equation printed on your paper. Okay. Plus, then what comes next in your product rule? The second thing, which is y. And then derivative of the first. So derivative of 6x is just 6. All right, equals. Now on the other side, you have a 2. So that's gone. That's a constant. So that's gone. And then derivative of y cubed would be 3y squared dy dx. That's the calculus. Now you have to do the algebra of getting dy dx by itself. So first, there are two dy dx's. We're going to subtract this whole term to the other side. So I'm going to subtract all of this over there. So this will be 6y equals 3y squared dy dx minus 6x dy dx. I had a little dyslexic moment here. Let me fix that. And then do you remember what you do once the dy dx's are on the same side? I got them both on the same side of the equal sign, so now what? Yeah, and we are going to divide it, but did you say factor? Good job. We're going to factor that out. So GCF, you'd be left with 3y squared minus 6x. And then to get dy dx by itself, you divide that to the other side. Now, I'm betting that doesn't quite look like what the answer says it is, but do you see how there's a 6, a 3, and another 6? We're going to reduce the fraction. These will all divide by what? 3. Good. So we'll have 2y over y squared minus 2x. That's our dy dx. And lo and behold, that is what the answer is that they told us. So we did it. Let me share my screen and we'll see what the points are worth. It was worth 2. 1 point for doing the implicit differentiation. So the first step, the calculus of it, the product rule and all the dy dx's. And then 1 point for doing all that algebra to get dy dx by itself. So that was worth 2. Get feedback from you, like how that went? Did you get the first? What happened then? Can we just talk about it?
The y times the
dy dx. Well, it doesn't turn into, it's a chain rule. So you're chaining on a dy dx.
Oh, like,
Well, no. No. Oh, did you try to, oh, you tried to treat it like a differential equation? Gotcha. It's going to say the word differential equation if that's the case. But thank you for talking to me because I can't clarify those kinds of things if we don't have a back and forth conversation. It'll say differential equation. Also, they'll give you an initial condition. They'll say f of 2 equals 17 or, you know, whatever it is. So that'll be in there if that's the case.
where we get the 3 y?
Oh, the derivative of y cubed is 3y squared. And then
Why we said the like the stuff at the very top? Yeah, like all of that.
all of that?
Yeah.
That's the derivative of this. We did the derivative of this equation. So the first part was a product rule. It was first times derivative of the second plus second times derivative of the first. That's your product rule. Equals, and then the 2 is a constant, so that was gone. And then derivative of y cubed is 3y squared dy dx. So we just did the derivative of this whole thing. Okay. So that was worth a point, and then all the algebra was worth a point. What's that?
For y you change on dy and x you change on dx.
No, for y you chain on dy. What it means is derivative of y with respect to x. When we get to part D, it's going to be respect, everything will be respect to time. So you'll be able to see the difference there. Actually, you know what? Let's do that. Let's jump straight down to part D. I'll come back to this. Can we jump straight down to part D so you can do a compare and contrast? All right. Part D, this is a related rates here. Particle is moving at the instant when the particle is at this point. Here's what I would do. I would write out x equals 1/2 and y equals -2. That's what that point means, but I'm just going to separate it into the x and the y. Do you see what I did there? Okay. Now, reading through, horizontal position is increasing at a rate of, and they even label this for you, dx dt is 2/3 units per second. What is the value of dy dt? So that's going to be our question mark. So dy dt is question mark. When the particle is at that point. I'm going to recopy the equation just so I don't have to keep on moving the paper up and down. If you don't want to rewrite that, it's printed on the paper for you. But we're going to do exactly what we did in part A again, except instead of dy dx, every single variable is going to be dt. Everything going to be respect to time. It's going to be the same thing again. So this is going to be another product rule. It's going to be first, just 6x. What's the derivative of the second? Because it's not dy dx, now it's dy dt. Good job. Gosh, I can't write today. So that's first times derivative of the second plus what comes next in your product rule. All right, the second thing, which is y, derivative of the first. So derivative of 6x is 6 dx dt. Good, there we got it. Equals 2, I know, right? 2 is still a constant, so that's gone. And then y cubed, that's going to be 3y squared dy dt. Do you see how part A and part D are almost the same thing? But one is y with respect to x, and the other is both variables with respect to time. I don't even think we're missing anything. I think you can just plug all this in. What was x? A half. So half of 6 is 3 dy dt is what we're looking for. So just leave that in there. Plus, actually, it's going to be minus. Sorry, because y is -2. So -2 times 6 be -12 times 2/3. All right, let's do 12 times 2/3. 12 times 2, 24 divided by 3 is 8. Good. Oh, did you get that? Good job. All right, and then y again is -2. -2 squared would be 4. 4 times 3 is 12. So 12 dy dt. Almost there. Now what? Yeah, get the dy dt's together. So if you subtract 3 dy dt over, what is that going to give you? How much? Yeah, 9 dy dt, and then you're going to divide that over. So -8/9 is the answer. Let's see what it was worth. I'm betting 3. I don't remember. I think it might be 3 though. Let's see if I'm right. Let me scroll down here to part D. No, it's only worth 2. Did you say lame? I feel like that should have been 3, but anyway, it's a point for doing the derivative. Look at point for doing the derivative, and then a point for plugging all the numbers in and solving it. I feel like that should have been worth more, right? Yeah, lame. Okay, let's go back and get parts B and C, which were, and like as much. So letter B says, find the coordinates of a point on the curve where the tangent line is horizontal. I'm just going to even stop there. What is the slope of the horizontal line? 0. So we're going to set derivative equal to 0. And if you even wrote that, you get a point. So that's why I always say at least do the setup. So we're going to take this. Did you write this on your paper? You got a point for that. 1-1. No, but that's fine. Because you know what? If you got part A, that was 2. If you got that one, that's 1. If the rest of it's a wash and you did okay on the rest of it, you didn't get nothing. You know what I mean? You just don't want to get nothing. All right. Now, if you multiply all of this to the other side, it's still going to be 0. And so you get y equals 0. Now, to go back to the problem, it said find it or explain why it doesn't exist. Well, here we're about to either find it or explain why it doesn't exist. You have to take y equals 0 and plug 0 in for y back in the original equation and see if you can get x. If you get an answer, that's the answer. If you get something that doesn't work, then it doesn't work, okay? I don't want to keep moving my paper up and down. You guys have this printed there. Can you just look at that? Okay, we're going to plug 0 in for y. So it's going to look like this. 6x times 0 equals 2 plus 0 cubed. That's what you get if you plug in 0 for y. How does that shake out? What do you get? You get 0 equals 2, which does not make any sense. So you would say no value with horizontal tangent on the graph, or however you want to word that. It's something in the capacity of version 1.
You just went like H.
No, they will not take just the letter H. At least abbreviate the word horizontal. All right, let's see what that was worth. B. It was worth 2. So if you set that equal to 0, you got a point, and then if you made it all the way to the end, you got a point. I will say I don't mind part B that much because you can get at least 1 out of it. All right. Now, part C was really weird, and I'm gonna kind of like give myself a little bit of room over here for this one. I don't love this one because it's mostly algebra. There's not really any calculus. Now, this one is kind of the same question, except instead of a horizontal tangent line, what did it say? Yeah, vertical. Instead of a 0 numerator, you want a 0 denominator. So you're going to take this denominator, y squared minus 2x, and set that equal to 0. Did anyone do that? Because that's a point. Did you do that? You got a point. If you even do the setup, you get a point. Okay. Now, which variable is going to be easier to solve for, x or y? Because we have to solve for one of them. Which would be easier to get by itself? X, because y has what with it? Or you'd have to do a square root. We don't want to do that, okay? So let's try and get x by itself. You would subtract the y squared over, negatives are going to cancel, and then you would divide by 2, or you could even just say 1/2 y squared, or y squared over 2. However, whatever your personal preference is, those mean the same thing, okay? Now we're going to take this and plug it back into the original problem for x. Like I said, it's not even really calculus, it's just a whole big bunch of algebra. All right, so everywhere there's an x, you're going to put 1/2 y squared. So it should look like that. I plugged the 1/2 y squared back in for x. Now we're going to solve that. Welcome to Algebra 2 class. That's really what this is. This is mostly an algebra question. 1/2 of 6 would be 3. And so this would be 3y what? Cubed, good. Equals 2 plus y cubed. Then what? What would you do? You want to get the y cubes together. So now what? Yeah, subtract this y cubed over. It'll be 2y cubed equals 2. So y cubed equals 1. So y equals 1. So we're going to say, so did we get an answer? Yes. Okay, so we're going to say vertical tangent at the point, what did we get? What was x and what was, oh, you know what? We didn't get x yet. I thought we were done because I ran out of room. Vertical tangent at y is 1. How would you get x? What would you have to do to get x? Plug 1 into the original thing. Let's see. If y is 1, this would be 6x. Are you getting what I'm saying? How it's all algebra and there's not, we didn't even do a derivative. There's literally no calculus. I hate this part of this problem, part C. All right, if we plug 1 in for y, that's going to be 6x equals 2 plus 1 cubed is 1. So 6x equals 3. So what would x be? 1/2. So vertical tangent at 1/2 comma 1. Let's see what that was worth. Probably the most out of the whole problem, right? It was probably, yeah, that was worth 3. Look, you said, because you nodded your head yes. If you even set that denominator equal to 0, you got a point. That's the one thing that I'm kind of okay with about it. Substituting this back in is worth a point, doing that algebra, and then plugging 1 back in at the end and getting x being 1/2 is worth a point. So that was worth 3.
How many points was B?
B was 2. A, B, and D were all 2, and then D was worth 1. Can we go back real quick and I'll highlight though, and let's see what could have been manageable. I feel like the first step on this could have been manageable. Now that we went over it, if you set that equal to 0, how about this one? If you set this equal to 0, so that's 2 right there. And then if you did this derivative, that's a point. And if you did this derivative, that's a point. So like, and those were practically the same thing. If you even got those, that's 4 out of 9, which is great, you know? So.
Yep.